Hydrocarbons, which are relatively simple organic compounds composed of hydrogen and carbon, are nonpolar molecules that are hydrophobic and highly flammable. Examples of hydrocarbons include methane, gasoline components, and benzene. Let's look at the representation of hydrocarbons in the polygonal model. Alkanes are saturated hydrocarbons, which means they have no double or triple bonds. The simplest alkane is methane gas that contains a carbon atom. Here we can observe alkanes up to 6 carbons, the hexane. The use of a more compact form of Fischer projection allows a better visualization. In the polygonal model, carbon can be represented as a small circle, as indicated here. Hydrogens is abstracted, remembering that each carbon has 4 covalent bonds. We could represent these compounds horizontally, but here we use the vertical notation preferentially. Interestingly, under normal conditions, short-chain alkanes are gaseous. Intermediate-chain alkanes are liquid, and long-chain alkanes are solid. Branched alkanes include compounds such as 2,2,4-trimethylpentane and 2,2,4-trimethylhexane, shown here in a compact form of Fischer projections. In the polygonal model, the branched carbon is omitted for better visualization. Note that 2,2,4-trimethylpentane has no asymmetric carbons, so the methyl bonds must be placed at an angle relative to the carbon backbone. In the second compound, 2,2,4-trimethylhexane, carbon 2 bonds need also to be placed at an angle, since this is not an asymmetric carbon. In contrast, carbon 4 is linked to 4 distinct groups. Thus carbon 4 is an asymmetric carbon. In the polygonal model, the connection must be kept horizontal. Hence, 2,2,4-trimethylhexane should be referred to the D form, and there is a distinct isomer L, seen here in Fischer projections and in the polygonal model. Asymmetric carbons and their representation in the polygonal model have already been discussed in a previous video, according to link on the comments. Alkenes and alkynes are unsaturated hydrocarbons with double and triple bonds, respectively. The simplest molecules in these groups are ethene and ethyne, better known as ethylene and acetylene, respectively. Other examples of these two classes are 1-butene and 1-butyne, in which unsaturation involves carbon 1. In the polygonal model, the compounds are represented by omitting the carbons involved in unsaturation. Other types of hydrocarbons are cyclical and may be aromatic, but these are not represented here in the polygonal model.
If you like this video, please like, share and subscribe my channel. Thank you.